Hello, good morning, good afternoon. Hello, yeah, everything is working. Hello, my friends from LinkedIn. Hello, my friends from YouTube. Yeah, draft routing is the temporary description in the user drawings layer. I can delete it because today we want to focus on improving the draft routing into a let's say into a beginning of the official correct actual routing. What I do in front of or in advance of this process is that I have to finish the fan out of all paths that can be involved in the routing. What does it mean? It means that, for instance, there are paths, especially in the lower right corner, that can affect the routing. Not directly, but inevitably the wires, the nets, the tracks coming from this area can influence the routing. For instance, the USB lines. You can see that the USB lines, the magenta air wires, are coming from the from the bottom right corner pads to this USB Type-C connector. So if I want to go, for instance, with this DDR C clock, like clock enable, I don't know if it means clock enable, but CKE line. Should I know what the CKE means? Probably I do. Probably I would. Probably I should, but I don't know. I'm not sure. Get back to my point. My point is that if I want to go with the CKE like this, with some meanders, some things that can affect the USB lines. Of course, there is still a lot of space, but yeah, my experience is, because I have reworked multiple designs, not from the very end to like to rework the finished design, but in the process. Like I have to get back a few hours because I forget to fan out some things, and when it seems that the design is a piece of cake, at the end I realized that, oh, I forgot to fan out these two lines, and these two lines must be routed instead of these lines or in the direction of the other tracks. You know what I mean. No, here. Undo, yes. So I want to start. And frankly, it wouldn't be easy because, yeah, it won't be easy. What's my track width for the grounds? Maybe the same as for the others. 762, which is the track width, default track width for the fan out. Yeah. Yeah, this magenta line. Yeah. Yes. This one. Can it? Yeah, it can fit here. Yeah, not optimal, but it can. Here. Yeah, as we said in the past, I should fan out like this in this direction, but it's not possible here. For that, I should have placed these capacitors other way. This is this cap, yeah, USB. Okay, so should be close to this, and this resistor is, yeah, here. Okay, okay. Okay. Yeah, it comes from here. Okay. Okay, okay. Can be like this. Yeah. The USB line can be tricky because, yeah, see, we have to review the USB differential pair parameters as well, because it's difficult to find out even a single track. Okay, we said that for the 100 ohm, we decided to use track width 0.0762 with the minimal gap, which is which equals to the clearance distance, which is very convenient because, yeah, let's say it's very convenient for routing and for dragging the pairs and modifications of the routing and tracks. But the result is that the final or calculated impedance, differential pair impedance, was 96 instead of 100, which is still inside of the tolerance. Plus, the manufacturer will be instructed about the controlled impedance design or impedance control design, and they can still slightly modify the track width, yeah, with the price of lowering the clearance or making the track narrower, but yeah, it's up to them, not me. But now I want to revise or review the 90 ohm differential pair, because now it's 0.12 and 0.11 millimeter, which is a huge. I can't even fan out a single track from the pad. Hello. Hi, Fernando. Yeah, the reason was explained in the previous part, but yeah, you didn't see it, and it's it's not what I'm going to say. I'm going to say that I calculated that the price of the PCB with just plugged vias, which means that the vias are plugged with epoxy and then plated. Filled with epoxy and covered with solder mask, which is a, let's say, default price or no extra money for the machine manufacturing. If you want to use the via in PET, it means that the via must be filled with copper, not with epoxy, with copper, and then plated with copper to make the final PET, because the it comes from the technology they use to create PCBs. It's like semi-additive technology, and this must be done. So drilling, plating of the vias, filling with copper, plating again, and finishing the top layer for the components. Result is that the price difference is about 500% from the standard epoxy-filled plugged vias to the copper-filled plugged vias that can be used for vias in PET. It means that I decided not to use via in PET because the price would be, instead of about $45 per 5 pieces 6-layer PCB, would be $350 for 5 pieces of the 6-layer PCB. So 50 or 350, because I'm training now, I'm learning in the process, but I want to manufacture the PCB and place and solve the components by myself. I don't want, and I'm not supported here, like sponsored, I don't want to spend a fortune about on the PCBs. So yeah, price difference. Thank you for the question. Great question. So let's review the JLC PCB impedance calculator. Capabilities, impedance calculator. Funny story. It's already loaded, but funny story. Fun fact. I've been working on a design for a customer from Europe, and they manufacture using as well the European company, but it's a contractor, and the PCB manufacturing is done in Asia. I don't know where, but definitely in Asia, probably China or India. Let's say China. And I asked them to give me the numbers for PCB stack up, like thickness of prepreg, cores, all the numbers I can use to calculating the impedance, because there are high-speed differential pairs as well. And I asked them for these numbers, and I've been waiting, I think, the third week, and no response. And they say that once they receive the numbers from the manufacturer, they will let me know. This week and the next week, they will be on vacation or the company is closed. So instead of supporting me with the numbers that everyone can find on iSlayer.net or glcpcb.com, nextpcb, everywhere, if you cooperate with the real companies, like not the internet companies, like the real companies, it means that you have to wait 3 weeks. I know there are the factory vacation, the factory holidays. I know, but the factory holiday started this morning, this Monday, and I asked 2 weeks ago for the numbers. Anyway, if you use glcpcb or iSlayer.net, you can get, for instance, here iSlayer.net. You go technical capabilities. You find your stack up, 6-layer stack up. Stack up is here, open, numbers are here, and the recommended numbers are here. It took how many? 20 seconds. And for the real companies, from the real companies doing the real job, because these are internet companies with limited capabilities and not perfect technology. Bullshitting. Everyone is bullshitting to cover their weaknesses. iSlayer nor GLC PCB. Anyway. Okay, so millimeters, 6 layer. We want 90 ohm because it's USB. Yes. And we want to use differential no coplanar on layer 1 with the bottom layer, no layer 1. Yeah, layer 1 is the top layer and the bottom layer is reference. And ideally, we want the clearance gap, which is 0.09. I'm not sure if it works, but we will see. Calculate. No, it doesn't work because the track is too narrow. So, what can be the real impedance if we use these numbers? How to find out? The trace width should be narrower than the minimal. It means the minimal is 0.1. Am I right? No, 0.762, which is allowed for, yeah, but only for PET. Yeah, okay, I understand. Yeah, it leads me to idea that anyway. Okay, so let's say 0.1. 0.1 should be working. Yeah, if we go, because there is 10%, I think, let's ask Gemini. What is the differential per impedance tolerance for a USB? I think plus minus 10%, because the USB is quite tolerant in this regard. But we will see. Gemini takes a break. Anyway. No. 85 with 0.09. Yeah, it's 0.11. So 85 would be doable. %, plus minus. Okay, that's fine. So it means I can use the same numbers for 100 because, as we said, it would be or 0.09 and 0.12. 0.12 is too wide. Yeah, 0. It's too wide. Let's check it, but I think I can't. Yeah, it's too thick, too wide. So it was 0.1, 0.1. Still. Yeah, the gap must be narrower. 12. Yeah, 0.1. It's not good. It's not good. Zero point one. Ah, 0.1. 0.1. Yeah, now. No, still not good. If I use lower clearance. No, but I think we are close. Ah, they use, okay. Yeah, I'm wrong. I'm sorry, I have a phone call coming. No, missed call. I'm back. Yeah, microphone is running, working. Track width 0.09, 0.09. Now it's working. And now we have to calculate what's the result. Because maybe outside of the tolerance. 0.09 is 0.09. The track width is below the limit, yeah. Yeah, and I think this. It's not about. Yeah. Of course, you can hold a command or yeah. I think yeah. If you hold a command key or control key, I think you can still route through because it overrides the DRC. But yeah, it's not the point. The point is that I want the PCB is manufacturable. And this is what I need to verify now, because maybe yeah. I am deep in the rabbit hole that it's not, that leads to an incorrect PCB or non-manufacturable PCB, because 0.09 is allowed. No, wait. Yeah. 3 mil. Yeah, 3 mil is acceptable only for BGA panels, not the entire track. Okay. Yeah, that's bad. 0762 is only for fanouts, not for the entire tracks. Yeah, this is correct. Here must be 9 as well. Yeah, only for fanouts, not for. Yeah, that's bad. What says the calculator? 0.09, which is maybe higher impedance because the track is narrow. Yeah, the wider track, so a higher impedance, lower impedance, 90. Yeah. Yeah, this time it's only there is no connector. There are only test points, but the other port is the normal port. This one. It means what I found is that all the tracks like this track can be 0.762, 0.07762, but this must be 0.09, not thinner. Here as well, which is very, very concerning. This is FO, but I want to use the 0.9. Mm. Yes. So whenever possible, like here, I must go for the here. No, it's 9. Yeah, sometimes it's possible because the pads are not equally distributed, but yeah, like this. But not here. I wanted to check here 762, like 3 mil, and now 9 mil. And I want to check. Yeah, this is the transition, and can be applied to teardrops, or it will work without them. Track to track. Yeah, it will work. Okay. So something like this I have to do. And for the differential pair, yeah, as I calculated, it's troublesome. 0909 is like 92. No, maybe no. Yeah. Sometimes it doesn't work. What's wrong with you? Oh. It's now what numbers should I enter? Mm-hmm. It's too narrow. So if I go with the impedance higher, No, it's not even possible. Yeah, because the higher impedance means even narrower track, of course. So 90, yes, even lower than 90, 85, 80. Yeah, 85. 88. Yeah, like 90. It will work. 90, 90. For both. It's not optimal, but it will work. Okay, fanning out of these lines. Yeah, something like this. Yeah. It's not optimal, but I hate it. Oh. Why so many pads are connected to this? Strange. W16. Where it is? The signal is called, will be CCC1. Here. Yes. CC1V8. Yeah. And towards W16. PA6, V16, PA6. It's a different signal. What does it mean? Yeah. I don't know how to solve it. V8 is a different signal, so why? I don't know where it is. V8. And a 0. That's the actual signal, yeah. V8. From here. So why is going to be W16? W16, there is an error in the schematic somewhere. W16 is PA6. This signal is where? Unconnected. Yeah, I'm 1 hour in, no, 45 minutes in the show and I'm completely lost. No routing today, solving this miracle. Why? Why is that even possible? Well, the other one. No, it's working. Yeah, the reason why I need to bother with this right now is that a similar issue can be hidden somewhere else, and why W16? So if I do this, what does it? What will do? What would it done? Not connected. That's correct. So V8 still connected to other ones. Wait. There is something. Here is something. Yeah. Maybe a line connecting all the paths. What's this? It's a label. Yeah, it's an empty label connecting all the paths together. Have you ever? Yeah, that's empty. Label cannot be empty, I know, but this one is empty. That's the reason. Empty label. Yeah, I can, as I said, I can delete the empty label from all the, I don't know, 8 pads, 8 nets from here, but it's not a definitive solution. It's a workaround for this occurrence of this error. I bet it comes from the Altium import, but I don't know how to solve it, like systemically. Let's do it again. If the error persists, yeah, it persists. So now I have to check the schematic file, which is MPU, and check for the W16 connection. No MPU, what's the sheet name? MPU. Our MPU, no, MPU, where's the MPU sheet? Am I blind? What's happening right now? What's going on? Tell me, what's going on? Sheet MPU. Sheet MPU. No. Well, hey, what's wrong? This sheet oh wait, I see. This is the, yeah, here. This is the main sheet. Yeah, and this one is the MPU. Oh, I see. MPU is like the logic name, but the physical name is here. The file name is here. Okay, I'm stupid. Okay. Let's wait for the code and give me a 10 seconds. Okay, I'm back. Let's find the W16 pad, and here. I don't know, I don't care. 4 occurrences. It's symbol. No. Okay, so from the symbol name, from the label name, W16 this. E-label. Because the label isn't connected with pad, with a pad. The label is connected with a net. So yes. But I know that both labels, this one and the false one are connected to the same net. And it's electric rule check while once, isn't it? There must be a warning or error. Yeah, here. No. This is legal. Here is the warning. Both CC80C1 and empty are attached to the same items. Yes. Yeah, label here, empty label. Empty label. Okay. So what we can do is to save the report, because we know that in the report the ERC found it. Empty label. Okay. So I can close this, and instead of the I will keep it open. I have to open the report. Empty label here, and we want to here. Empty label is here. Here is a coordinate, but okay, how to do it? In here. Okay, so 100, the coordinates are here on the bottom. Yeah, it's not easy. It's not easy. 87 and 100 here. Here is the empty label as well. Yes, it is. I'm really sorry that I'm not routing today yet, but okay, so this one is solved. Only one? No, only one. No, only one. Here is one as well. It's like another 1176. Yeah. Okay. Okay. So the other occurrence is not empty label, but it's like label empty connected to only one pin. So all these. No. Or it is. Let's check it. The first occurrence is here. Label connected to only one pin. Warning. Label I2C2SCL. Here. No, I3C2. I3C2. No. It's only this. So this is why. I don't know. The empty label. Only one. But I know about two. This one and the previous one. So let's check it. Yeah, it's still there. For instance here, K6. K6. I don't know where it is. K6. Here. It's PZ3. It's unit C. It's power. No, it's port. The ports. Here. Yeah, here. Yeah, it's. I don't know how to solve it. And DRC says so, what? It's like 299.72. No results. No. Let 4. LED 4. No results. So this error wasn't identified, but it's there. So what should I do? Tell me. If there is somebody watching me, what should I do? How to find the empty labels that connects multiple paths together and ERC can't see it. here. Global label appears only in, no, it's not a global label, it's a standard small label, local label. 4 connections points, spice issue, assigned footprint doesn't match. Ignored tests. Yeah, that's fun. So you can edit the ignored test from here, but this window stays on top. Very convenient. Ignored. Global label, okay. 4 connection points. And spice issue and assigned footprint doesn't match footprint filters. The assigned footprint doesn't match footprint filters. I don't know what's footprint filters. All other aspects are identified as error or warning, as an error or warning. So does it mean that I need to I don't know how to solve it. I am paralyzed. Okay, let's find another occurrence, and let's find the way how to do it. Case 6. Okay, case 6 is still here, but I solved it. Case 6 is solved in the schematic. J3, 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 J3 here. Okay, so if I check it, no, not this one. Yeah, there is this sucker. So when I marked the label, the official label and the net, it means that the label, the empty label is not selected. And if I drag it, I should expose it. No, it's not exposed. So does it mean that I drag it along with the, yeah, like the empty label is at the end of the net. So let's find another way. How to do it? If I mark the end of the net, it, yeah. If I mirror the label, here, yes, this is the sucker. Connection name is USB CCC1. So let's check the ERC again. Fine. USB C CC1 ADC. This is the symbol that yeah, that's the empty label occurrence. and this R and R is the same. But I think, yeah, only one. Okay. So again, USB CC1, it's the only three other, so yeah, the ERC doesn't see it. It's hidden to ERC. What? Yeah, it's still there. What did I do last time? That I mirrored the label. What should I do? Is it still there or not? I lost track. Yeah, it's still there. If I move the label, and delete the net. Okay, so I have to delete all the nets. I have to select the labels. I have to move them. And I have to delete all the nets, which is not possible to do. No. It's not here. So I can't do it globally. So I know that both are affected by this error. Yeah, not this one. What's the lesson learned from this? Don't import Altium design schematics. Unfortunately, this one. Because the import is not perfect. I don't know what to do. I wanted to work on the DDR3 routing, and now I'm hunting the invisible villain. And I can't do it automatically because ERC doesn't help me. So I have to delete and redraw all the nets and labels. Yeah, I don't need to mirror the label because it doesn't help. I just need to move it. I don't know what to do. I don't really know. I don't know. I have to do it for all the symbols. Okay, I am so unhappy now. V8. Yeah, at least 4 more, but maybe more. Okay, I will solve this because I hope if there is more than one another occurrence of this error, I will find it. So it's D3, D3, B6, B11, and C10. Okay. I can't use the search because it doesn't search through the pin names. Oh, it does, but you need to check this box. These three. I can't see it. It doesn't work. I want to search only through pin names, not the other things. I don't know how to do it. I don't know how to do it. PI6. Here, PI6. So D3 is PI6. B6 is PD4. B11, PD6, and C10, PD5. Okay. So PI6 here, LCD sync. So let's verify the method I used before. So move the label, delete the track. Yeah, here is the sucker. So D3 is done. PD4, PD4, 5, 6. There is a group of these snakes. PD4, 6, 5, and 6. Here, so the same method. So move the label and delete the net. Yeah. You know what? I will back up this. And if anyone of you can help me report this error, I will send you this file, and please do it for me because I can't speak programmer language or Git language or any other Git version control language. I don't mean that it's purely KiCad error that must be fixed. I think the ERC should find it. That's what I believe. So please help me if there is somebody who is watching this willing to help, please do it. Okay, let's get back to DDR3 routing because today I haven't done nothing or anything. Okay, fan out of this sucker. Okay, it's fine. It will work. I need to find the most difficult. Yeah, the most difficult. It's funny. It's funny because every freaking net of this design is the most difficult to route. No, I'm just joking. The goal is to make all other traces that group match. Okay, you establish a target net based on the most difficult to route path. Path. So let's make a list. How to identify the most difficult to route path. It can be the longest path. Okay, so let's check all the nets. 48. Still 48. Yeah, 48 in the reds. And in magenta, yeah, only shorter. Okay, so the longest is 48, which is probably this one. Yes, or 49, very quickly. And it's, what's the logic name? DDR CKE. That's the trouble one from when I started. It can't be a coincidence. It can't be a coincidence. Okay, so this is the not the most difficult to route, but it's the longest track, which means something. So it means that we should optimize the routing because it's a draft routing and the longest path may come from the unoptimal routing, but I believe it means something. Last week I said something about we should change the routing because it goes all around the module instead of go inside it. But I successfully forgot what I mean. Forgot what I mean. What I meant. So let's check the first one. Of course, this element is not needed here, but I don't know if there would be a need for this in the final routing, so I am keeping it. So if you watching it and screaming out loud to me, hey, there is a false useful fanout, yeah, stop or stab, I don't know how to say, delete it. Yeah, I'm keeping it by intention. Yeah, this was the third one. Yeah, the issue is definitely it seems that there is a simple route for this signal. Yeah, like let's try it. Yeah, like yeah, not this one. Yeah, of course I can delete this useless pad, but what else? Yeah, let's do that. Let's do that because we can always undo the thing. Yeah, this one, another one. Yeah. So we can go with all the vias above. It means that we sacrifice everything for this one signal, and it's not systemic because we need the fanning out or fan outing vias to direct the bottom right corner. That's the first thing, and we don't want to sacrifice everything for one thing. So it means that I'm leading to an idea to take this draft routing as a something that we can lead on and really take the longest path as the most difficult to route one. I don't know. Can we? What are the constraints? DQ to DQS, so data signals to data strobe signals. Plus minus yeah, this is 56 mil plus minus 1.42 millimeter. So the data lines must be quite tightly length tuned. The data strobe to clock is really benevolent, plus minus 22. And the AC signals, which are addresses, why is it missing? Why was that missing? So it probably means that it's missing in the PCB as well. I must accidentally delete it. But well before the yeah, that's fine. That's fun. It's very fun. Of course, there is a missing line. No, this is a reset. It was M3. M3, yeah, it's missing, of course. Perfect. That's that's fun. It's AC signal, which means that it's to be routed in the inner layer. So this one, and it goes, so it was not covered in the let's say bit swapping procedure, but luckily it works this way. I will keep it. 21, 23, 4, not 4. Yeah, I found this like not error. It's a feature. It's not error of this, because when there is a, let's say, this is not an unconnected line. It's something like semi-connected, and then the analyzer doesn't work. Sometimes it doesn't even work when there is like the extra segment in the track. You know it from your work with KiCad, and sometimes it even happens. I solved it or working on this type of mistake a few days ago when there was a differential pair, and there was two pairs above each other, like half of the route and half of the path, and then the entire path. And the inspector calculated like two neighboring pairs, and the first one was like 28 and the other one was 48. And I said, what? After I deleted the routes, because yeah, I started deleting the tracks to see when there is the mistake, when there is the cause. And when I deleted the track, I saw that there is another track beneath. So yeah, it's 21, 23, 22, 21, 24, like 28, 28, 30, 30, 23, 5, 4, 6, 4, 6, 5, 7, 8, 9. Okay, so it seems that all the AC signals are inside of the tolerance of about plus minus 3 millimeters. 22, yeah, plus minus. Oh, this one is short. But mainly because probably of this false segment. Yeah, 21. 21. If you are using this, you, based on the errors I was talking about, or I'm talking about, you always need to see all the entire track, because sometimes it measures like part of it. And in this case, it was like 15 instead of 21. But the error, the useless segment, the extra segment can be close to the end, so it can measure 19, and you can base your decision on this false measurement. So you always need to see the entire track, because if you are too zoomed in, you can miss this detail and you can lead you to a miss like direction. 26, 23. So we said 48 is the longest and shortest. 23. Yeah, 23. It's really short. But it's what? Yeah, ODT. It's not a control signal, but yeah, you can count as a control signal. Yeah. "12." This one is really short. 12. Yeah, all the ones coming from the top right corner are rather short. It almost seems that if we keep all these tracks, like slightly length tune them to be yeah, we have 48 one, the 48 one. So we should, yeah, we should definitely make like this one to be 40, not 32. 32 to 48 is like, yeah, both DQ and DQS and or P groups must be tightly length tuned, rather tightly. Yeah, we need to length tune these, definitely. But to make this one, the 32 one, to be like 47, we need some space to make it like extra 15 millimeters. But it takes it takes space. So if you want to make meanders, it takes not only like 0.27 millimeter, it takes like 3 millimeters. So it means that if all these tracks needs more space, the longest one wouldn't be 48, but like 75, because it won't be here. It can be like here, or even further. So that one can be the most difficult to route. But not so much, because if you see it, yeah, it's very thin, but if you see it, it goes here, and there is almost no red signals on the top. So it means that I can make this. Yeah, this is why I was talking about the fanning out of all the resting signals, because it can easily affect routing of other signals. Yeah. So now I know that I must go through this, and if I go here and delete this track, not the entire track, but like the bottom segment. Now it's, if I count even with this small segment, but let's say that we don't need it right now. Yeah, the inspector says 22. So from the longest track, it's now one of the shortest. So the draft routing was great for the bit swapping, but not so great for identification of the most difficult to route path. So I can easily delete this and even this part. Yes. What else can be changed? This one, yeah. Well, it seems that the draft routing was useless. Yeah, it really seems to me right now, because I made all the bit swapping, but I didn't keep in mind that I have to optimize the path at the same time. My intention was to connect it, not to find the optimal way, optimal path, how to solve it. I can continue with the bit swapping. I can spend weeks on bit swapping. But I don't know how to do it. I don't know. I really don't know. I don't know. Let me take a 20-second break and I will get back in 20 seconds. Okay, I'm back and I'm thinking about this. Let's check. Oh. I don't know how to do it. What I want to reach, what I want to do, I need to, the result must be a length-tuned routing between the MPU and the DDR3L. Now we have a draft routing that answered our question of how to connect the MPU ports with the memory ports. Now we know that this connection is working, it works, and we know that we can optimize the path of all the signals, and if we keep the order of the tracks coming from the MPU and coming to the memory module, we can length tune them, and interconnection is working. The interconnection converges to a final state of connected design. But it doesn't mean at all an optimized and optimal PCB layout. And now I don't know how to change the direction to the optimal PCB layout instead of the only connected layout. Now we have connected layout. Connected layout is good, but it's not optimal. Yeah, exactly. It's good, but not optimal. It's okay. This design is okay. Maybe even worse than okay, but let's say okay. And we need optimal. We need almost the best design we can achieve at the moment. With the technology we have, it means the CAD tool and knowledge and skills. So how to improve the okay design to an optimal one? We have to start doing something, because by staring at the problem, it doesn't solve the problem. It only makes it worse and bigger, because the longer I stare at it, the more desperate I am. So I have to do something. What I'm doing right now is I'm taking a screenshot of this, because it can be used later as an evidence that it was done, and as a helper of the routing. And what bothers me the most, what bothers me the most is these lines, all these, because they are crazy long, and there is like 1, 2, sometimes 3 big corners and 1, 2 like mild corners, not so sharp corners. So I can unroute these tracks, not the entire segments. Like, I think if we want to keep this interconnection, like after all the bit swapping, we can unroute the segments coming from the module, because inside of the module we don't do much. We can't do much. Yeah, there is like small manipulation space, or space for our dance, small dance room, but not much. And then we can try to optimize. The longest track now is not the DDR CKE. The longest track out of this group is 38, 39, 39.7, 41, 41, 41. Yeah, so this one, 40. This one, the inner one. I wouldn't expect it. And it's a differential pair. Yeah, it's differential pair with the data strobe signal. And we know that the data strobe the data signals and strobe signals must be tightly matched. Data strobe signals to clock are loosely matched, and all address controls are, let's say, tightly matched to clock. The clock is the reference signal here, and data strobe signal is the reference signal here. Data strobe pair and clock pair. A clock pair is mainly for the AC signals, because the data signals are matched to the strobe signals, and the strobe signals are loosely matched to clock. So data signals are matched to strobes, and address and control signals are matched to clocks. So if the strobe is the reference pair for the length tuning, length matching, we should start with the strobe signal, or at least identify what's its or their path. So we identify that this DQS0 pair, DQS0 pair, so P/N is 41.66. Now, where is the other one? The other one is a part of the upper signals, and this is the strobe. The strobe in this case is very short, surprisingly short. DQS1 PN, Yeah, just the technical note. I know that these streams are getting longer and longer because I'm getting lost, more lost and more lost. But I want to continue for a while. So, yeah, I will continue for at least 30 more minutes because I realize that the 2-hour streams are sometimes, or maybe usually, too short. So I will continue because I got to this point, and if I conclude the session next week, I will start from another point and completely lost this without, yeah, noting it, of course. So 17.57 is the DQS1. A huge difference. I don't know how both DQS must be matched in between. But there is like a big length difference. So in my opinion, if I take the DQ as a 0 signals, which is the lower byte, am I right? 0 is lower byte, yeah. The lower byte must be length tuned to the data to the lower data signals. It means or D0 to D7 and DQ as 0 must be plus minus 1.4 millimeter, which is 56 mil. Yeah. And D8 to D15 plus DQ S1 must be again tightly matched to 1.42 millimeter. Yeah. Again, D0 to D7 plus DQS0 tightly matched, and D8 to D15 plus DQ strobe 1 again tightly matched 1.42. But I suppose that both these groups can't be matched so tightly because this is the reason of the strobe signal. The strobe signal marks the validity of the data signal. So it means this is the reason why the data signals must be tightly matched to the data strobe signal. But the strobe signal for lower byte doesn't do anything with the data signals over higher byte or the higher strobe signal. So it means we have two groups. Group 1, D0 to D7, tightly matched to strobe 0. Group 2, D8 to D15, tightly matched to DQS1. And then we have, I want to make it separately, we have the clock signal, which is very loosely, I don't know why, but they say, length tuned to the both groups, plus minus 22. So it means if I take the group 1, which is the lower byte, so group 1, I should make a note on the screen, but I am writing it by pen, so yeah, please forget me. The group 1 is lower byte, must be plus minus 22 to clock, and group 2, again, plus minus 22 to clock as well. So it means that the group 1 can be let me say, 30 millimeter, an example, 30, and if the clock is 52, an example, the other data signals, DQ, group 2, can be easily 74. So it means that the maximum difference of the length between group 1 and group 2 can be up to 44 millimeters, which is quite promising, or forgiving, let's say forgiving, quite forgiving. Now we have plus the issue with the track width. So yeah, today is not a good session, but back to the question. Upper byte with the differential pair, which is here. Differential pair is 7.57, we said. And if we take this length as a average length, yeah, we can, as an average length, all the other signals of the group, of the upper byte group, must be, let's say, 16 to 19. So let's check. Too short, but not so much. It's okay. Too short, but not so much. Too short, again too short. Too short, too short. Too short, as we saw. More data of the upper byte here. 30, definitely too long. So yeah, I will continue. Maybe it's time to make a table, but like a spreadsheet. But yeah, we will see. A 13. No, it's the address, not data. I'm sorry. I'm looking for data. DQ15 here. Too short, but not so much. Too short. Yeah, DQ more than 8. DQ more than 8, not here. DQ. Yeah. Yeah, it seems that the most difficult, what I wanted to say that instead of find the most difficult to route path, like globally, I would rather say that we need to establish a target net of each group based on the most difficult to route path, because of the length tune tolerance. So it means if we have data strobe 1 signal length of 17.56, 57, let's say 18, then as I verified right now, it's the longest path of the entire group. So it means that if I keep this pair as is, all the others should be length tuned to be within the tolerance band of 1.42 millimeter, plus minus. So the width of the tolerance band is 2.8. Then we take the length of the data strobe 0 signal, which is 41. Let's verify it. 41.6, 42, let's say, or 41, 41.6 to be precise. Then all the other signals of this group should be matched again to have the length within the tolerance band of plus minus 1.42. It means roughly from 40 to 43. Yeah. So then, if we take the length of the data strobe signals as we have right now, 41 and 17, we have the band is, if I take the worst, like 42 like the longer and 17 like the shorter, 59 divided by 229. So this is the central, and 42, there is 12, so 12.5, and 17 is again 12.5. Of course, we are in the middle of the range. So now we are 12.5. If we length match all the group signals, all the data 0 to data 7 to data strobe 1, data strobe 0, and D8 to D15 to data strobe 1, we will be within the band of 12.5 millimeter plus minus. So it means that if we place the clock signal to be between 17 and 42, we would be matched. So clock pair is now, let's find the clock, probably here. No, it's strobe. Where is the clock? It was like somewhere here. Here is the clock. It's not connected. I have to finish the routing. Yeah, I know, because the pair is now incorrectly routed. It must be corrected. Oh shit. Yeah, you can see there are more issues than before. Now the plus minus, the clock signal is 17.96, so let's roughly, okay, 17.96. So it means that if we length tune all the AC signals, which must be length tuned within 3.55, so all the AC signals to be between, right now at the moment, between 14 and roughly 21, then we are length match as well. So let's check the AC signals. AC signals are all the magentas. Is it correct? Yes, all the magentas. So let's check. Yeah, inner layer. Okay, so again, this is the clock. It's like 19 maybe and 18. And let's check all the others. Yes, these are mainly controls. So 25, 24, 22, 23, 21, 21, too short. 16. So let's say 25 was the longest, 25, and these ones are much longer. Let's check them. Yeah, 28, 29, 28, 28, 30, 30, 24, 26, 27, 29. Okay, so these are more closer to 30. Yeah, with some possibility, with a possibility to make them slightly longer, with a price as I described before. So we have to spread them, so it won't be 32, it won't be 38 at the moment. Okay, so all the ACs plus minus 3.55. So 14 to 21, yeah, too short. So the clock is too short. We have, again, we have 29, 20, 20, 30, 29. Yeah, I don't, yeah, the net expector maybe have some, no, it probably doesn't. Group name, yeah, we can create a new group. Maybe there can be like D0 to D7 plus DQ0. I don't know. I don't know how it works. Group by net class. No, it doesn't help. Group name pattern. How to use / to indicate a regular expression. Group name. So DQ lower byte can be our, no, it's not a logical name, it's a group specification pattern, or okay, let's ask Gemini. Oh, I need a regular expression covering all the names listed below, and these are DQ0 to DQ1, DQ3, 2 to DQ7, and then DQS0 P and DQS0N, if it's even possible. Probably yes. So let's copy it and place it inside of the slash. Yeah, there is a custom group that, oh well, it's really a group name. I don't know, I don't understand the note about the regular expression. So lower byte is here. I'm making it a bit bigger. Lower byte, and we can add net name ddr dq0 already in use. Okay. So probably this feature is useless. Never mind. There is no anything like if I select more of them to give me some statistics like the variance, the average length, etc. It would be really helpful to see the spread, yeah, the variance, the longest, the difference between the longest and the shortest track. Never mind. Never mind. So we can do like this, and this would be our we can even include them, highlight them. That's fine. I like it. But unfortunately, they doesn't keep selected, which now I would expect like change the color or group them. Not possible. So total length 38, 39. Yeah, the spread is okay, almost okay. Yeah, 32 is an outlier, 34 outlier as well. But it's not. It doesn't look bad. We have to work on 32, 34, 37, 37, but the rest of them are okay-ish. Like if the DQS is shorter, it will help us. Can we make it shorter? The DQS. Probably not so much, and probably we will make it even longer because of the length matching. Again, I will select all of them, the entire group. What is DQM? Yeah, DQM as well. DQM, we have to count with DQM as well. DQM 0 is what? is the meaning of the DQM QM1 and DQM0 signals at DDR3L. Mask, data mask. Okay, so we can count with the masks as well. Not we can, we have to. So not only these ones, but the mask as well. So M0, am I right? M0, DQM0 here, 41. Yeah, luckily it's very similar. Yeah. So this entire group of signals should be matched, must be matched to the DQS0, which plus minus works. Yeah, there are some outliers, but yeah, it will work. The 1 extra millimeter or 2 millimeters of the majority of signals can be solved easily. 10 millimeters of the DQ5, it will take some time and space, but it will work. So this variance is quite good. What's the other group? This, and these two. Clear highlighting and highlight these nets. Yeah. This is the longest is 1756. Yeah, as I identified, it's the clock, not clock, DQS1, yes. And the shortest is like 12.39, DQ11, yes. But as well, can be done. Can be done. There is plenty of space here, and it can be done. What's this? DKE. CKE. CKE. It's slow today. Clock enable. So it's a control signal group. Yeah. Control signal. Okay. What's the length of the CKE? 2. It's part of the control signals. Yeah, if it's 22. if it's control signal, if it's a control signal, it should be routed in the inner two, in the magenta, which no, it's not control signal. CTE is generally treated as a control asynchronous signal. Okay, so it's not to be length matched. That's fine. So DQ0, DQ5, 15, M1, and strobe. Yeah, we said this is fine. And the addresses, control signals. Must be matched to clock. Clock is 17, it's very short. Yeah, unfortunately, maybe the cause is on my side. I don't know, but yeah, I'm sorry. But fortunately, you won't be missed because I haven't done much today. 21, 17, 20, 30, it's outlier, but not so much. 29, 30, 28, 29, 25. Okay. So the clock, first things first, I think clock must be enlarged to about 25. And the DQ S1 signals, it means the upper byte must be lower to 25 as well. If the clock is longer to about 25, it makes the entire situation more friendly because all the AC signals are almost matched right now. Yeah, clock signal must be longer. Can we make clock signal longer? And can we find a shortcut to or hotkey to the inspector? Yes, we can. What can be? What can be the shortcut? I think only, yeah, it accepts only control and, yeah, control and shift. which is a combination Control-Shift-N. No, yeah. Place the footprint anchor. Okay, so Command-Shift works. So if I press Command-Shift-E or I, it works. So Command-Shift-I. Okay, so I make it bigger. Okay, fine. So the last things for today, can we make the clock signal longer to be about 25 millimeters? Probably yes. I'm not sure, but probably yes. So if we delete this, almost the entire thing, because as we said, we must start almost from 0 because of the length, not length, because of the track width. It will be tough. It will be really tough. Okay, so there is plenty of room on the top layer. So if I go like this, yeah, for the sake of test. Yeah, it's not optimal. This track is shorter. Yeah, shorter on both ends, which is not optimal. The longer one is the longer one as well here. Okay. Oh, there is something. So okay, it can be fine-tuned later. What's the length now? This is exactly what happened to me last time. Yeah. Mm-hmm. $21. Okay. So it means that we can be more aggressive . $26. Yeah, we can get there. 26. So we will see. I have to make a note for next week because I will forget everything. So note for August 3, 4, 5, 6, 7, 7th. Take the DDR signals as 3 groups. Lower byte, DQ0 to DQ7, DQS0 plus and negative, positive and negative, and DQM0 upper byte, DQ8 to DQ15, DQM and DQS1, then AC signals, which is A0 to A15, then Rassen, Sassen, etc., and matched to DQS0, matched to DQS1, matched to clock. DQS0 to clock is plus minus 22 millimeter. DQS1 to clock is as well. So very loose. Okay. I will continue. Now the clock is 26, about 26 millimeter. Plus minus 1.4, plus minus 1.4, plus minus 3.5, plus minus 22, plus minus 22 millimeter. Okay, so 26 is our clock, and we have to match the AC signals to 3.5 plus minus. And what's the current state? I forgot. So no, this one. This instead according to the clock. Yeah, probably this. When we in and chip select as well. It's so user friendly, so user friendly. And this one. 22, 21, 26, 20, 30, 29. Okay, so we have 26. I would really need the average length and the variance to see it. But yeah, we can take 26. So all of the signals must be within 30 and 23. So within 23 and 30, so BA2 is too short and A7 is too long, including A13. But 21 and 22, so Reson and V write enable must be longer as well, but shortly, but slightly. Yeah, it will work. It will work. Okay, so you can see that we are almost matched, and yeah, and then we will see. So make a quick, I'm going to make a quick check for all these. 32 is outlier. 41, yeah, must be longer, slightly longer, 32 to be solved, and we are done. And these ones plus S1, S2, which is reference 17, 12, 13. Yeah, we have to make either the S1 shorter or all other ones longer. We will see. How long can be? Yeah, I think this one can be made shorter. Longer. Shush. It's 17, so I forget. These ones and these ones. 17, yeah, shorter or all of them longer. Yeah, shorter or longer. Yeah, that's very convenient. You leave the inspector bigger, and again it's only a sign that nobody using these tools, because nobody is complaining. 17 can be made shorter. Probably yes. Yeah, if we move the entire thing. Okay, so make EQ S1 shorter. Okay. I have to conclude the session because we are almost 3 hours in the show and I have a lot to do. Thank you for the session. If you want to support me, fedevel.com. Yeah, let me show you, because it's the only way you can support me. And yeah, KiCad for beginners is the first course. The KiCad for makers is the second one, both on fedevel.com. If you enroll the course, you will redeem the coupon for the PCBA assembly at next PCB for free, completely for free. Makers, more advanced boards; beginners, essentials in KiCad. So if you enroll the course, you will redeem the coupon, and the coupon is in the case of KiCad for makers more valuable than the price of the course. So please consider supporting me this way. Thank you for watching. Thank you for being here. And next week I will be more proactive, I promise. Bye-bye.